contains. So contains is going to loop, right? And we move the exception out because we said contains doesn't need it. The one, because contains return true or false. But when we move and found, we still record that current pointer, right? So for example, let's look at this image. Let's say I'm looking for J. So current L pointer, let's just move current, right, to where J is, which is here, right? So this no longer there because it's keep moving from iteration here. And when it equals, it's return file is equal to true, return file right away, right? Because it's break out the loop. But the pointer is still there. That means when I do get next, before get next, if I do next, it's going to return the one next to that location. So when we do this, we see that the pointer is still currently pointing to J. If I call get, I mean next, not get, it's going to return L, but we actually want next to start from the beginning because the point of next is iterating from the beginning to the end. Then that's why we actually don't want to do this because this code is awkward when you set this twice. You should set this when you add the same, when you do contain the same, your current always change. But before you do next, you should make sure your pointer always go to beginning. Right, and we don't need previous here, so just set current. So now if we put it here, there's going to be a problem again. We're seeing that next always go to beginning. It's not moving to the next. So to solve this whole issue is there's a problem is with the current being shared, the pointer being shared. We not supposed to implement this. So that's why we never have this implement the iterator interface right here. But the one who's supposed to implement this is when you use it in your application. Okay, application is supposed to, just like this example, right? This is an application already, and that application is supposed to implement the iterator. And our linked list that we create already have add, right, remove, and so on. But you have to override that and implement your own iterators to use in your own application with next, has next, remove. And to resolve that, always put the pointer to the beginning, like in this case use array index 0. Has next, always increment that to the next one. So you don't want to implement, so we don't want this in here, right? Has next not supposed to be in here. Reset not supposed to be in here, right? Get next is not supposed to be in here. Has next not supposed to be in here. iList doesn't have to do this. Okay, but when you use this in application, the application is supposed to implement the iterator and use it. Okay. Like for example, on your test case, this is just like your application. So if I want this to implement, right? implement this first, and we do E. I'll enter and add implemented methods. There's a problem with the exception. Let's go back and see what happened to that. Okay. Reset. We didn't have any exception here. Okay. All right, so then this need to implement this, right? To do next reset and use in this program. So the user has to implement your own iterator for the application, which you're required to do that. This one was trying to test, so we pretty much just don't need this because it's no longer inside the linked list. Has next is get next to. I think this is part of thing that we have to implement. Yeah. All right. Reset. We no longer need to test that. We could test on itself here. Oh, reset is the one from override. That's why. All right. Come back to linked list. Now, our add should be fine, right? Let's review again for if we add something in between. We did try from the beginning. So now if I want to add I should be something in between, right? So I'm going to create a new node, right? So create a new node. Which is I. So this line of code is executed when we add, we pass I in. And we're not going to do is empty because not. Set pointer. So C is going to go here now, no longer there. Right, it was there before when we tried to do contains, which we never reset it back until we try to use again. We're going to reset it right now because when we add current pointing here, previous pointing here, right, from these two lines, and we start to iterate, right, while current not equals to null, which is not, is pointing to the first, the beginning of the list. So if the elements compare to, so we start to compare I compared to G, element is I and G, is it greater? Which one is greater? I. Then we get greater, which is not less than. We never do the if, right? Then we just say previous equals to current, and then current equals to current.getPointer. So we make previous state where it is, and we can move our current pointer, right? Move it away to the next one, which is current.getCurrent. Now we move it to H, right? So we start to compare again, right? Come back to the loop. Current not equals to null, which is not elements now I compared to H, right? Which one is greater? I, which is no longer less than 0, is greater, right? Not less than 0, then it's going to move your previous E to current. So we move P and we move current to J, right? To the next one. So let's look at, we start to move now, current out and previous out. So now come back to previous, actually now go here and current is here, right? And then we come back to the loop again, current not equals to null, which is not equal to null, is equal to J. And if elements dot compare to, which is I compared to J, which one is greater? Ooh, J is greater, then it's going to be less than 0 now, right? So we found the location then. So now we have to see if this is inserted at the beginning, which is it's not at the beginning because the LR pointer is not equals to current, right? They're not the same. LR pointer is G, current is J. Then it's going to do else, which is it's going to insert in between, right? So how do we insert this? We say previous dot set pointer to new node. There you go, previous. So we set this H to new node. So no longer point to that one, right? So now it's going to set to new node. So it's going to point to this one, which is I's new node. And then it's going to do new node dot set pointer after exit from else. New node dot set pointer to current, which is this new node dot set pointer to current because current is pointing to J. So we have just insert that, and it's still in order G, H, I, and J, right? And then we done, we break, right? Because no longer need to loop anymore. We found location, so break out the loop, and current not equals to null. Current still there, so that means we not insert at the end. We just increment it, and we done adding. So let's see if I want to insert O. Right, so we create a new node named O. Alright, so let's see if this add is going to work. So it should go to the same O here, which is new node. Not doing that, not empty. Set all current and all the pointer just get to beginning again, right? Alright, so this is your C is going to move here, and P is going to move here again, right? And no longer there because we moved them. Now we start to iterate the loop again. Current not equals to null, which is not equal to null. So we're going to find location, right, by comparing O to G, which G and O are always greater than G. So we are keep moving your current, right? By doing that, previous equal to current, current to the next one. So pointer keep moving, right? So it's going to move to H, and previous is going to move to H, and then C is going to move to I, right? And keep doing that until it's go to the end, right? So eventually C is going to go here, and P is going to go here, current and previous, in the same manner that we've seen before, right? Because O is still greater than N, right? Then it never get inside the loop here. I mean inside the if here, it's still in the loop, but never gets inside the if here. And then